Alright guys, so today's notes are going to be on the instantaneous rate of change. So the notes that we did together on Wednesday were on the average rate of change, and we used that slope formula to find average rate of change or slope of the secant line. But we were still looking at the instantaneous. What happens right at a certain point, and we couldn't find it. It was the indeterminate. So today we're going to look at how to do that without doing what we did on Wednesday, where we were looking at numbers that were really close and what it was approaching. Today we're going to have a more final answer for this. So the first thing I want you to do is just find these values. This is all just algebra review. Okay, we should be able to do this. I'll do the first one with you. So if I have 1 over x, if f of x is 1 over x, then f of a is just going to be 1 over a, and f of a plus h would be 1 over a plus h. So you're just plugging whatever is in parentheses in for x. So for my next one, if I have g of x equals x squared minus 4x, then g of a would be a squared minus 4a. And then g of a plus h, I don't know what's going on with my mouse here. G of a plus h would be a plus h squared minus 4 times a plus h. And I'm going to simplify this a little bit just because I feel like we need a little algebra practice. It's always good to practice our algebra. So this here I would FOIL. So I would think of this as a plus h times a plus h. And then I'm going to distribute that negative 4. So I would get negative 4a minus 4h. So now I'm going to FOIL this. So when you FOIL, you get a squared plus 2ah plus h squared minus 4a minus 4h. And actually, there's no more simplifying I can do here. I can't combine any like terms. This is the only a squared. This is the only ah, the only h squared, the only a, the only h. So this is what you get. Okay, and you're going to see a lot of that kind of algebra today. All right, so we're going to brush up on our algebra skills. Okay, and then finally over here, if I have h of x equals square root of 4x plus 1, then h of a is going to be the square root of 4a plus 1. And h of a plus h is going to be the square root of 4 times a plus h plus 1. So this will end up being 4a plus 4h plus 1. So this is just some algebra review reminding you that whatever is in parentheses, that's what we're going to plug into our original equation. And I'm using a and a plus h for a reason. That's because that's what we're going to be doing today. Okay, so you'll see that in just a moment. Okay, so on Wednesday we talked about secant lines, and a secant line was a line that connected 2 points of a curve. A tangent line is a line that touches a function or intersects a function. It touches a function. It touches a function at 1 point. Okay, so let's say I have a parabola here. I'm going to do an upside down parabola. And I have a point right here. A tangent line would go right here through that point this way. Just like that. Okay? Now, you might ask, why does it have to be that way? And don't write this down. I'm going to draw in a different color, but don't write this down. Why can't the tangent line be there? Or here? Or here? Okay, it's touching at one point, it's going through. Remember in geometry what the definition of a line is. A line goes on forever. So if I put arrows on these, this is eventually going to touch it in 2 places. So that's going to be a secant line. Okay, if I would extend these, eventually they're going to touch somewhere. Okay, so remember, lines do go on forever. So tangent lines, it's going to just touch once, like this. So it's going to touch the curve. It's like it's just skimming the side of the curve there. Okay, so that's going to be our tangent line. Now, if I want to find the slope of this, okay, think of what this point is. This point is some value a, and then f of a. Okay? Whatever my x value would be here, and I'm just using a as an example, then f of a, that's going to be my y value. If I would plug this into the slope formula, just that point, we would get 0 over 0. We would get our indeterminate. Okay, so if I'm going to define the slope of this line, maybe I could find a point that's very, very close to it. So a plus a little bit. So if that h is very small, it's going to become much closer. Okay? So if I wanted to find the slope of that, remember slope is y1 or y2 minus y1 over x2 minus x1. So that's going to be f of a plus h minus f of a, that's y2 minus y1 over x2 minus x1. That gives me f of a plus h minus f of a over h. Notice that my a's subtract away. Okay? This right here gets a special name. This is called the difference quotient. Okay? And that is 2 points on a tangent line where h is just adding a little tiny bit from a. So h might be 0.01 or 0.001. It's just adding a little tiny bit so that these 2 points are super close together. But if I want to know what this is going to be exactly, I really want h to be 0. Because if h is 0, then it is the slope right at that point. So that's what I want. Okay, if it is 0 though, again we get the indeterminate. We get 0 over 0 and that doesn't help. So instead, what I can do, if I want h to be 0, instead of having it equal 0, we're going to find the limit. We can find the limit as h approaches 0. So it doesn't exactly equal 0, but we see where it's heading. We see what it's going to be, what it's going to look like. We can predict what's happening. So I'm going to find the limit as h approaches 0 of f of a plus h minus f of a all over h of the difference quotient. Okay? This is what we're going to use to find the instantaneous rate of change. Or you might hear it be called slope of a tangent line. Just like on Wednesday, the average rate of change was the slope of a secant line, the instantaneous rate of change, what's happening at one point, is the slope of a tangent line, which is 1 point. You might also hear this be called the derivative. Oh, I can't spell. Let me try again. That's why I don't teach English. It's the derivative of the function. The derivative at any x value tells you the instantaneous rate of change or the slope of the tangent line. That's what derivatives are. Okay, and we're going to focus a lot of our time here in calculus on finding derivatives. Okay, so here's our first example. And again, this is going to be very algebra heavy. Okay, so find the instantaneous rate of change for f of x equals x squared at x equals 2. Okay, notice now we don't have an interval. If I wanted to find the average rate of change, they would have had to give me 2 x values, and we would do our slope formula like we did on Wednesday. But now it's asking what's the slope at that exact point. So again, if I would use my slope formula, I would get 0 over 0. I would get the indeterminate. I can't do it. So instead, I'm going to find the limit of my difference quotient. So the limit is h approaches 0 of f of a plus h minus f of a all over h. Okay, and you will not have to have that memorized. Okay, you don't need to have the difference quotient memorized. Okay, I will have it on the test for you. Okay? You just need to know how to use it. So, f of a plus h, let's focus on this part first. F of a plus h, I am taking a plus h and plugging it into f of x. Okay? So, I'm going to FOIL that. So I get a squared plus 2ah plus h squared. Okay? That's what a plus h equals. Now, f of a, again, I'm just plugging into x squared, so that gives me a squared. So now I have the limit as h approaches 0 of a squared plus 2ah plus h squared minus a squared all over h. Okay, so here's f of a plus h is right here. And I plugged it into there. Here's f of a is equal to a squared. And I plugged it in right there. So I get f of a plus h minus f of a. Now I have to simplify. So my a squared subtract away. So I'm left with 2ah plus h squared all over h, which I'm going to cancel something here. I can factor out an h. Now I've canceled. Remember, canceling creates the whole. Remember that whole indeterminate thing that we did before on our last limits tests? Once you canceled, now we can find our limit. It's the same thing. So I'm left with the limit as h approaches 0 of 2a plus h. So when I plug 0 in for h, I get 2a. And now, what value are they asking for? They're asking for when x equals 2. So 2 times 2 gives me 4. Okay, I know that was a lot. Okay, so I'm going to re-explain it all again. Start with the limit of your difference quotient. This is what we start with right here. Limit of our difference quotient. And that's what we're going to start with every single problem today. On these notes, every single problem starts with that. So, based on your function that they give you, this time it was x squared, find f of a plus h and find f of a, and we're going to subtract them in our numerator. And that's all going to be over h. Now, after you simplify, something has to cancel. That's how we find the indeterminate limit. It has to cancel. If it doesn't cancel, then we can't find the limit. So once it cancels, I can find that limit, 0 in for h, so I'm left with 2a. And now they want to know what's happening at x equals 2, so I plug 2 in there. If this had said x equals 10, I would have plugged 10 in for a. If this had said x equals 1,000,000, I would have plugged 1,000,000 in for a. Okay, so that x equals 2 doesn't come into play until the very end. After you've found your limit, then you plug a in and you're finished. Okay, let's try another one. All right, so again, to save room, I'm not going to write out the limit of the difference quotient up here. So if you want to look at the previous slide, it's the same thing. So the first thing I'm going to do is find f of a plus h. So I have a plus h squared minus a plus h. And I'm just using this as my function here, x squared minus x. So I'm going to FOIL this again. Distribute my negative. Okay, and that doesn't simplify. That's it. That's what it is. And then f of a is going to be a squared minus a. So now I'm going to subtract those two. This is my difference quotient. So I have the limit as h approaches 0 of a squared plus 2ah plus h squared minus a minus h minus f of a. And that's all over h. So now I'm going to simplify. Which, for this first part, I'm just distributing my negative. Okay, and now I can see my a squareds subtract away, and my a's subtract away. That's what I'm going to cross out. I'm going to uncross them again so you can see what I'm doing, but all those a's are going to cancel out. So I'm left with 2ah plus h squared minus h all over h. And again, something has to cancel somewhere. So if I factor an h out of my numerator, now I can see those h's are going to cancel. So I'm left with the limit as h approaches 0 of 2a plus h minus 1. So now I'm plugging 0 in for h, so I'm left with 2a minus 1. And now my last step here is that they're asking for when x equals 3. So I'm going to plug that in here for a. So 2 times 3 minus 1 gives me 5. Okay, and we're doing the same thing that we did on Wednesday, just a different way. On Wednesday, if I'm going to define this at x equals 3, I would have taken my intervals like 3 to 4, and then 3 to 3.5, and then 3 to 3.001, and you would have looked at the trend, and the trend would have been going to equal 5. So now we don't have to do this process anymore. Instead, we're using algebra and calculus with limits to find out what that is. Okay? Alright, I'm actually going to end this video right here because, to be honest, I have a meeting to go to and I ran out of time. So I am going to make another video for the last 3 slides. So if you have any questions about this stuff, you can ask me, you can rewatch the video. Just email me if you're having trouble. If you want to meet sometime on Monday, I have a lot of open free time on Monday. We can set up a Google Meet if you're having trouble with this. But look for the second video that will finish up the last 3 slides.